Okay, let's unpack this.
Let's do it.
We are diving deep into the technical specs of a really quite impressive piece of kit, the A-Neuvideo ANI AOC 100. It's a fiber optic HDMI active optical cable,
Right. A long one,
a
too.
very long one. And our mission today is basically to figure out how modern tech lets you send these massive high-speed video signals, perfectly, over what seems like an impossible distance, 100 meters. That's 328 feet.
Yeah, and this isn't just any cable. It's really specifically designed for professional AV installations. Think large venues, conference centers, that sort of thing.
Because standard copper cables just can't do that kind of distance with this much data.
Not reliably, not at 18 gigabits per second. You'd need, well, bulky amplifiers, maybe power injectors along the way. It gets messy.
Yeah.
This cable uses light. That's the key insight.
Okay, so let's talk performance. What are we actually getting at the other end 100 meters away?
You're getting true 4K Ultra HD resolution, and critically, at a full 60 hertz refresh rate.
Smooth motion, high res. But for the pros, the color accuracy is often, well, everything.
Exactly. And what's really fascinating here, technically speaking, is the color fidelity. This cable delivers full 4.4.4 chroma subsampling.
No compression on the color signal at all.
None. Zero loss of color information across that entire 100 meters. For anyone doing serious video work, color grading, high-end displays, that's huge. Achieving that distance with 4.4.4 is really something.
And that kind of purity, it must demand some serious bandwidth.
It does. We're talking a maximum throughput of 18 Gbps. That's the full spec for HDMI 2.0.
Which covers your 4K 60 hertz needs. And I see it supports all the usual suspects too. HDR10, Dolby Vision.
Yep, all the modern standards. HDR10, Dolby Vision, plus the essential stuff like HDCP 2.2 for content protection.
Okay, so copy protection is handled. What about things like audio return or device control?
Got those covered too. ARC audio return channel is supported, plus CEC for device control, and EDIDE, which is, how the source and display talk to figure out the best settings automatically. It's fully featured.
All right, so let's get into the how, the active optical part. Why fiber? What makes it so different?
Okay, so this is where it gets really interesting. Copper's big weakness, especially over distance, is interference. It basically acts like a long antenna.
Picking up noise from everything else around it.
Exactly. EMI, RFI, electromagnetic, and radio frequency interference. In complex installations with lots of gear, that noise can kill your signal integrity. Fiber optic cable, however.
It uses light, not electricity, for the main transmission.
Right, so it's completely immune to all that electrical noise. That's a massive advantage for signal purity in busy environments.
And physically. I imagine a 100-meter copper cable rated for 18 Gbps would be, well, pretty thick and hard to handle.
Oh, absolutely. They can be massive, stiff. This fiber cable, though, it's incredibly slim, just a 4.8 millimeter outer diameter.
Wow, that's tiny. Like thinner than a standard pencil?
Pretty much. Makes it way easier to route through walls, conduit, tight spaces. Big win for installers.
Okay, signal integrity, physical size.
Yeah.
But the power thing seems almost like magic. You're saying no external power adapters?
None. No extra power bricks, no signal boosters needed halfway. It's truly plug and play.
How does it manage that over 100 meters?
It draws a tiny amount of power, less than 250 milliwatts, which is minuscule directly from the HDMI port itself. That standard plus 5V pin in the HDMI connector.
So the source device, like a player or PC, and the display device provide all the power it needs.
Correct. The conversion from electrical HDMI signals to optical and back again at the other end is incredibly efficient. It uses tech like 50125 multi-mode optical wire and these tiny 4-array 850 millimeter VCSEL laser diodes and photodetectors.
Transmitting 18 Gbps over 100 meters on basically the trickle of power from the HDMI port? That's kind of astonishing.
It really is impressive engineering. Shows how far optical tech has come.
Now, with this kind of specialized high-performance gear, support becomes really important, right?
Yeah.
Especially for the pros relying on it.
Definitely. You need reliability not just in the product, but in the supply and support chain.
And looking at the bigger picture here, there's a specific relationship behind this product. A-Neuvideo, the manufacturer in Texas, they have a long partnership with HDTV Supply in California.
That's right. HDTV Supply is their platinum authorized reseller, and that relationship goes way back since 2002, actually.
Wow, over 2 decades.
Yeah, and that kind of long-term stability in the supply chain is critical for professional equipment. It means consistency, availability.
And for the customer, the person actually buying and installing this, what does that translate to?
It translates directly into better support and peace of mind. Buying through an authorized channel like HDTV Supply gets you the manufacturer's 3-year warranty.
Okay, solid warranty.
And importantly, free US-based live telephone support, lifetime tech support. If you're running a critical live event or managing a complex install, knowing you can get knowledgeable help on the phone immediately, that's invaluable.
Absolutely. So, pulling this all together, what does this cable really represent? What's the takeaway?
Well, in a nutshell, it's the synthesis of fiber optics and the HDMI standard. It lets you deliver high bandwidth, high fidelity video over really long distances without any of the traditional headaches of copper, the bulk, the power requirements, the interference issues.
It just works right out of the box over a football field length.
Pretty much. It solves a major problem for large-scale AV setups.
Okay, so that leads to a final thought then. Something to mull over. Given that you can now reliably push a massive 18 gigabits per second over 100 meters, using only that tiny bit of power from the HDMI port itself, what does that enable? What kinds of applications, maybe temporary setups, mobile broadcast rigs, or even dynamic reconfigurable stage designs? What becomes practical now that was just too difficult, too bulky, or needed too much external power just a few years back?
That's a great question. It really opens up possibilities for flexibility and scale that were much harder to achieve before. Definitely something to think about.